Alright, welcome back to part 2 of this 6-cycle oddball series. Today we're going to make what's called the body back plate. It's more like a front plate to me, but they're calling it a back plate in the book. It's made out of a piece of 1/4-inch aluminum, and basic dimensions are about 2 1/4 by 2 5/8. So we're going to get started on this here pretty directly. I realized in my last video I was talking a lot about things that I did on the DRO, and you really couldn't see it. So the digital readout, of course, is a very, very useful tool to use, and I should have been showing that all along. So in this video, it's going to be kind of an experiment. I'm going to put my iPhone, I have an old iPhone, I'm going to put that kind of looking at the DRO, and then, try and drop it down in the corner somewhere as a small overlay so you can see what I'm doing and what I'm seeing on the DRO while I'm doing it, because I feel like that would be really helpful. Today we're going to use a function called a bolt hole circle, or a bolt circle, which is a great way to hit your 4 points for a bolt circle. Without showing too many of the dimensions here in this book, I'll show you kind of what I mean. So these 4 points right here are on a circle, and we're going to use the DRO to locate those 4 points, which I think will be pretty sweet. And I am going to modify this slightly. As I mentioned before, Joe on YouTube has a whole series on building this engine, and he used some screws to mount the cylinder to this plate instead of studs. I think studs is kind of a silly design. Fiddling with little tiny 632 nuts is not all that fun, and I always felt like 632 nuts look really big for the screw size that they are, so I'd rather not use them. I think they're going to look kind of clunky, and we're going to basically hide some cap screws, which will be a perfect setup. So without further ado, let's hop over to the milling machine and get this thing going. Over here at the mill, what I did was found this back edge closest to me, found this edge on the print. This will be the left edge, and this would be the bottom edge. So basically everything on the plans are laid out off of these two sides, and I have the part flipped upside down. So what I did was, like I said, found these two edges, and I came over and made this center point mark with my center drill, and I drilled it with an 1/8 inch hole. And the reason I drilled all the way through, for now, if I want to flip the part over, I have this as a reference point to indicate on later, because we're going to cut a big hole here. But what I care about primarily on this side is my 4 positions for my bolt hole, or my bolt circle, and to lay them out correctly. So over here on the DRO, what you do is zero out your X and your Y for the part. So now we're going to work of that center point, and then we come down here to the bolt circle function, and it wants a radius. The plans in the book gave us a diameter of 1 9/32. Of course, the radius is half the diameter, which is 640. So 640. Number of holes is the next question. It's 4 holes. Or right here, it shows that in the plans as 45 degrees. And I don't know what that one is, but as you can see from your 0 point, that A, I think that's a Greek letter, that shows 45 degrees in the plans. So we click create, and I think, if I'm not mistaken, there's a way you can see this. I'll have to play around with that. I think there's a way you can display that on the screen, but that's alright. So now what you do is just drive to one of those points. Oops, I overshot it. So you get to this point, zero that, come over here, get this point. You'll see that my DRO has tenths. I don't think the scales for my DRO are that accurate to actually accurately read tenths, so I just use it for more of a reference of the high side, low side of it versus, oh, there we go. That's how you can access the what points you want to see. But yeah, I just use the tenths for the high side, low side of what we have going on. Like I said, I don't think they're that accurate anyways, so we'll just use them to our advantage like that. Now what I'm going to do is just spot both of, or all four of these holes. Just give it a little dimple like that. And then let's go to hole number 3, which is this way. Like I said, I'm just going to spot these, get them all squared away, and make sure it looks correct before I commit to drilling them and potentially wasting the piece. Because I don't want to do that. At this point, with just a little tiny spot drill, I can still come back and fix the locations if there is a problem, which I think I got it correct. And then come back to point number 1. Yeah, this looks good. So I can probably go through and drill these now to what the clearance size for a 632 is. That looks exactly like it's supposed to. We can double check our measurement here and make sure we are indeed 640 off of the hole. Yeah, as close as I can eyeball it. That looks really good. So let me drill these 4 holes off camera, and then we can come back and probably cut our center hole in this setup, because I feel like why wouldn't we do that, you know? Use the center point that we already have. I'm just going to go through and time-lapse this for you guys, just to kind of show you the workflow that I have going on. So this is a number 28 drill, which should be clearance size for a 632. The head of the cap screw measures 140 thick, which means I need to come down 140 after this part touches. Which is right there. So zero that on my DRO and come down 140. After some thought and consideration, I determined there's no reason I can't bore this hole with it in this orientation. That will make it basically perfectly concentric with these holes that I just drilled. That way I don't lose any concentricity whenever I flip it over. So I just wanted to point out, as you can see right now, I'm still centered up on this hole, which is from the previous operation, but I need to get back to the center. So if you look right here at the DRO, we still have the number 1 hole selected. So if we unselect that, now we move over here, we can get right back to our center position, which is why I like using that bolt circle function versus doing the math and having to come back to it. What I'm going to do is slowly work up through some holes here. I'm not going to show you each and every hole that I drill, but I'll bring you back whenever it's time to use the boring bar. Alright, I got this opened up with a 3/4 inch end mill. We're going for an 875 bore diameter, and right now it's basically at 0.7. So try and get you into shot a little bit here. That's 10. That's 20. So the hash marks on here are 1/1000th each, but it takes 1/1000th off the entire hole, which means it takes 2/1000ths out of the diameter. So that's something important to know. I'm going to ram this down through a whole bunch of times and get us to 0.875. Just double check our measurement here, see where we're at. So that's 721, 722, something like that. Here's the final cut. It's basically a spring cut. I need to take 2 thou out of it. See how we did. That looks like 875 to me. Okay, I think we're ready to flip this part over and drill all of our other hole locations. Got this part swapped over. We have several holes to drill on it now. I did center punch everything with a center punch, which is more of a reference for me than anything. So what I'm going to do now is edge find once again and use that and come use my punch marks as a way to double check. So first hit this edge. Edge finder kicked out. So that's the x-axis. Come down here and use my vice jaw now. Zero that one. My probe, whatever you want to call this, on my edge finder is 200 thousandths, which means I'm 200 thousandths away from the actual edge right now. So for my Y, in this case, I need to roll in 100 thou. and we'll 0 it again. I know there's a way to like set up tool offsets here in the DRO, but I don't know how to do that, so I generally just don't worry about it. And then we need to roll in 100 thousandths this way. And now 0, 0 is dead on this corner, which is exactly what I need it to be for all of the layout that I need to do. We have 4 mounting holes, 1, 2, 3, 4. They all get drilled clear for 632 and then countersunk for 632. I'm only going to drill one on camera because once you see drilling one hole, you can see drilling all the holes. So those 2 holes are up 5/16 of an inch and over 1/4. So up from the bottom 5/16, over 1/4 from that side. So let's first go over 1/4, which is 250. And 5/16 is 312. So that's the center drill, which is always a great idea to use a center drill. Helps to keep your bit from walking. This is a number 28 drill. Just double check, make sure we have clearance on that parallel, which we do. And then I need to counterbore this. Again, that's the screw head measures 135, but I'm going to go 140 just to make sure it's going to get there. 0 my Z. And come down my 140. And that's it. Let me get the rest of these holes drilled off camera, and that's just about it for this part. 2 more small operations and we'll be done. Got the next to the last operation here. I already rough sawed this notch out with my bandsaw. Can actually get you zoomed in a little bit on this. I already rough sawed that out with the bandsaw. So we need to leave an 1.25 inches here, and we need to go down a 1/2 inch on that. So I'm going to come down and touch right there. Barely touch it. 0 my Z. Come back off of there to protect that surface finish. Then we need to come down 0.5. Lock that in. Make sure that it's in 2 cuts. Sorry, that might be kind of obnoxious. I'm going to 0 out my X here. So that was extra loud because this is actually sticking up too high, really. So it was chattering a little bit. So this needs to be 1.25 inches, which is 1/250. Need to take about 25 thousandths more off of that. think that should pretty much get us there. 10 more. Alright, that is the last milling machine cut on this part, I do believe. Well, that about sums up part 2 of the 6-cycle oddball build series. This is the completed part that we ended up with. Turned out really good. The plans call for there to be a circle cut, or a diameter, a radius, whatever, cut across the top. But I'm going to wait until I have my cylinder, and then I'm going to transfer from the cylinder to this and make them both match perfectly. But overall, very quick and easy piece to make, and I'm glad you stuck along till the very end. If you enjoyed the video, please don't forget to like, comment, and subscribe.